to Game of Engineering. Today we will start our mission to the GATE 2021. So in today's class, we will start our main topic, strength of materials or mechanics of solids, or MOS or SOM. So here is our syllabus for strength of material. And before starting today's session, I will just brief about today's session. Today's session we will discuss the detailed syllabus of mechanics of solids, and after that we will just go through the general equations. And after that I will discuss some questions from 2020 GATE. That is the previous case. Some questions are in connection with the MOS. Actually, we are not discussing the whole theory portion today. We will just start the today's topic and we will discuss some questions related to MOS from the previous GATE exam. So here is our syllabus. First we will start with the stress strain relation, elastic constants and Poisson's ratio. This will be discussing today. And after that we will go to the Mohr circle, a plane stress and plane strain, thin cylinders, shear force and bending moment diagram. It's a very important topic. Surely you can expect one or two questions from this topic. And concept of shear center, deflection of beams, torsion and circular shaft, Euler's theory of columns, energy methods, and thermostress, strain gauges, rosette, and testing of material using universal testing machine, and hardness and impact strength. This is the detailed syllabus, and we are expecting most number of questions from this bending moment, shear force, shear relationship between Mohr circle. In the last year also, they asked question from Mohr circle, bending moment and shear force and torsion related areas. Okay. I didn't see any question from columns for the. I have analyzed the first series for today's class. We got two sessions for the mechanical. So in the first session, I haven't seen any question from these two in the columns and like that. Anyway, I got two questions from bending moment and shear force diagram. Okay, we'll go to our topics. So here is our topic: stress, strain, elastic constant, Poisson's ratio. So we'll start with the stress. Stress is explained or defined by the internal resistance offered by a body against an applied load. So we are not giving any definition in the GATE exam. We will just need the equation. Stress is given by the equation load by area. So we will be writing it as P by A. Where P is applied load, A is the area cross section of the body. Second thing, we will be discussing the strain. Strain can be defined as the change in length by original length. If you apply a compressive load, the length of the beam will reduce. If you apply a tensile load, the length of the beam will increase. Anyway, delta L can be written as change in length, either elongation or compression. Okay. So, and divided by total length. So both these having the same unit mm or millimeter. So strain can be defined as don't have any unit. Okay, delta L is equal to epsilon into L. Okay, but delta L is the change in length and L is the original length. If after studying stress and strain, we will directly go to our topic, our main constant, that is called elastic constant based on Hooke's law. So as per Hooke's law, stress is directly proportional to strain, or we can replace the proportionality with a constant called Young's modulus or modulus of elasticity, E. So we can write stress by strain is equal to modulus of elasticity. And from this we will be writing the equation for change in length. Stress can be written as P by A, strain can be written as delta L by L. So we can rewrite that delta L is equal to PL by A. This is a very important equation. We will be using this in many times in a previous, not in previous year, 2 or 3 years before, I have seen a question relating to this equation. It's a basic equation, not a direct. We cannot expect direct question like this. It will be application level question. So you can understand what you mean by application level question while doing one or two example today. Okay. So this is the equation for elongation of a bar due to the applied load. So it is given by PL by A, where P is the applied load, L is the length of the beam, A is the area of cross section, E is the Young's modulus. And after that, we will be going to elongation of bar due to its self weight. So we have to study the elongation of bar due to self weight is given by WL square by this small WL square divided by 2E. It's a specific weight. And we can replace the specific weight with the total weight of the beam, which is given by specific weight into area of cross section into length of the beam. So it can be the first equation can be written as WL by 2AE. Okay. And we have to study one more equation. This is the elongation of a bar. Actually, this is circular bar. For circular bar also we will be writing PL by AE. So in terms of A, we will be using pi by 4 d square. And if we are dealing with a tapering bar, so that means at the one section it got a diameter D1 and another section it got a diameter D2. So if we are dealing with a tapering bar, our equation for delta L is equal to PL divided by AE. Similarly, it remains the same. Instead of A, we will be using pi by 4 D1 D2. Okay, so 4 will go to the upwards for PL by pi E D1 D2. This is the equation for elongation. So these are all the basic equations that we are using in connection with the stress strain. Okay, and next comes the elastic constant. So we have to study mainly two equations. E is equal to 2g plus 1 plus mu. E is equal to 3k into 1 minus 2 mu. So here is a small trick to remember this equation. So in both these equations, left hand side is okay, E, that we can remember. And we have G and K, and inside the bracket 1 plus or minus 2 mu. Okay, so we have to concentrate on this plus or negative sign and 2 and 3 and 1 and 2. Okay, these constants. So as per alphabetic order, the G, A, B, C, D, F, G, H, I, J, K. G comes first, so we'll give a 2 first letter to the G and 3 next letter to the K. And as they are standing from the front, G got a positive and K got a negative energy. Assume that these are students sitting in a class as per the alphabetic order. So G is sitting in the front, so G got a positive energy, and K is sitting 2 or 3 bench back, so K got a negative energy. So just try to remember, not questioning the students or arguing. Not take it as a joke. Okay. So left hand side is okay. E is same for both, and after that, if you are dealing with G, G is the first letter, so we'll be adding 2. K comes the second letter, we'll be adding 3. So G, as it G is the first letter, we'll be adding positive sign, and K is second letter, we'll be adding negative sign. As G is the first letter, we'll have only 1 mu. As K is the second letter, we'll got 2 mu. So these two equation is the basic equation. From these two equations, we'll be deriving another equation by removing the constant Poisson's ratio. So Poisson's ratio can be defined as the ratio between lateral strain and linear strain. So lateral strain means strain along, not perpendicular to the direction of force. Linear strain means strain along the direction of the force. So if we apply any tensile or compressive load, any block, it will elongate or compress. So this that is called a strain. So it will, if the compression is along the direction of the force, that is called a linear strain. If the compression or expansion is perpendicular to the direction of the force, that is called a lateral strain. So that's all about the basic equation, and we will be discussing the more equation in the coming class. And here is some question that I asked for the GATE 2020. Actually, it is an application of our mechanics of solids, and this topic comes from the section bending moment and shear force diagram. So we'll directly go to the question: magnitude and reaction of the force. Magnitude and reaction of the force at joint C of the hinge beam shown in figure is dash. So we have to calculate the reaction force at point C. As it is a hinged section, we need to consider either left or right or left of the section. As we have to calculate the reaction at C, we'll consider this section only. So we'll be writing this as a separating this as a hinged beam, and we will be taking the moment to the right of the point B. So to the right of the point B, we got a 10 kilonewton per meter. It's a uniformly distributed load. So its intensity will be 10 into its distance, that is equal to 10 into 4. And it will be acting at the midpoints. So the midpoints, here it will act. So it will be at a distance. It will act here. It will be at a distance 2 meters from the support. So we'll be multiplying 10 into 4 into 2. It's a total moment. That is opposed by the reaction at C. So here got a reaction RC into the distance from the point B is equal to 4. So we can calculate the value of RC as 20 kilonewton. So simple question. So it's a 2-mark question. So scoring 2 marks in GATE exam will shift your rank to very higher level. Okay. We'll go to our next question. Actually, it is again it's a bending moment and shear force diagram, but it is came as a combination of fluid and solid. So in fluid, we'll be discussing about immersed plate and center of pressure. So we had to consider that condition also for solving this problem. So here we got a barrier. At one side we got a water up to a height of 4 meters. On the another side we got water up to a height of 1 meter. So we'll be calculating. The width of the barrier is given as 1 meter. Treating the beam as a cantilever, taking the density of water as 1000 kilogram per meter cube and acceleration due to gravity 10 meter per second square. Maximum absolute bending moment. Maximum bending moment. We have to calculate the bending moment. That's why I told that it's a question from shear force and bending moment. We have to calculate the maximum bending moment developed in the cantilever in kilonewton meter. Again, it's a 2-mark question. So first we will calculate the what is the force acting on by this water. So it is given by the equation rho g a x bar. So rho g a is the total water weight and it will be acting at the midpoints. X bar is the midpoint as the plate, first plate. So got it 4 meter wide. So it will be x bar is equal to 2. For the second plate, that's towards the right side. Again, rho g remains the same. Area of the plate for the first plate is 1 into 4. For the second side, the other side, it got water is up to a height of 1 meter only. So we'll be taking the areas 1 into 1, and we'll be take the value of x bar as 1 by 2, so it's equal to 0.5. So this is the total force acting on the plate. The next thing we have to calculate where the force will be acting. Actually, the force will be acting at the center of pressure. Center of pressure is given by at the 1 by 3 of the total height. For the first plate is at a 1 by 3 of the total height of water. That's a 4 into 1 by 3. That's equal to 4 by 3 meters. For the right side of the plate, 1 by 3 of the total height of the water. For the right side of the plate, the height is up to 1 meter. So it will be 1 into 1 by 3 meters. So we got all the values in terms of force and distance. Now we are going to replace it as a cantilever beam. In the first figure, we are having a 5 kilonewton. So smaller force 5 kilonewton at a distance 1 by 3 meters. So this distance. And second one, it's an 80 kilonewton. So we got from here 80 kilonewton at a distance 4 by 3 meters. So by using these two, we'll be calculating the bending moment at the point A is equal to 80 into 4 by 3 minus 5 into 1 by 3 is equal to 105 kilonewton meter. Actually, it is a simple question. But by seeing this, most of the people will skip, or they will actually they don't have given any option for this. So most of them will skip this question. Okay. The next question again it's a MOS question in connection with the design of machine elements. So the only thing we have to study from the design of machine elements is the maximum shear stress theory. So maximum shear stress theory means the beam will fail due to shear stress. So for the first beam, that's equal to 80 kilonewton, and second beam is equal to 80 kilonewton. Both are tensile and compressive load. They are called the normal stresses. So most of them will consider that these beam don't experience any shear stress. So it will have the minimum shear stress. So it will not fail. And the third one, bending moment. This also will not experience any shear stress. Only shear stress will be experienced by the torsional loads. So this beam will fail. So the question is, the beams are subjected to these loads. So as per maximum shear stress theory, it should not require that the beam should experience any shear stress. It says that if the shear stress reaches the value of tau max, it will fail. The tau max is given by sigma divided by 2. So even the beam is experiencing a normal stress, we can convert the normal stress into shear stress, maximum shear stress, by the equation dividing the normal stress divided by 2. So we can calculate the shear stress experienced by the bar. So using that, we have to calculate the shear stress experienced by all the 4 bar, and which got the lowest value, that will fail. Okay. So we'll be calculating the shear stress for the first beam. So we'll be calculating the value of sigma, and the value of tau max is given by sigma by 2. That's greater than 20 megapascal. And as per question, they have given maximum shear strength is 20 megapascal. So if for the second beam it is 16 Newton per mm square. For the third beam it is 30 Newton per mm square. Here is a correction. Actually, we'll be experiencing a bending stress. Bending stress is given by m by I is equal to sigma by pi. So m is the bending moment that they have given as 320 Newton meter. I is the moment of inertia. So here they have drawn it as a rectangular beam, but in the question they have given it as a circular beam. So for rectangular beam, it's equal to b d cube by 12 or d by 2, as b and d are same. We can write it as d cube divided by 6. So actually this is circular beam, so we'll be replacing it with pi by 32 d cube. Anyway, pi by 32 d cube will be smaller than this quantity. The stress will be larger than 30 Newton per meter square. So among this, the circular shaft with the torsional load got the minimum stress. So that is the answer. Tensile and circular shaft with the tensile, the compression load. And the last one regarding the Mohr circle. So first of all, I will explain what is the Mohr circle. Mohr circle, in which Mohr circle we got x and y axis. In the x-axis, we will be plotting the value of sigma x and sigma y. If sigma x and sigma y both are positive, we will be plotting towards right. If anything is negative, we will be plotting towards the left. And we will be plotting the value of tau xy in the y-axis. So in this question, the state of stress at a point in a material is given by biaxial tension. So biaxial tension means, so a block with the tension in the x direction and the tension in the y direction. Both the sigma x and sigma y are positive. Okay. If one of the unit sigma, if one unit on the sigma y plane is 1 megapascal, the Mohr circle representation of the stress is given by. So it is both sigma x and sigma y are 10 megapascal, and both are positive or negative. Either positive, either negative. They haven't mentioned whether it's a positive or negative. So we can assume that both are positive or both are negative. We can assume any value. So how it will be? So for drawing a circle, we need 2 points at least. So here they have given the value of sigma x and sigma y 10 megapascal both in one direction. So we'll mark the value of 10 here and we'll mark the value of 10 here. So with only 1 point we cannot draw a circle. So options are circle with a radius of 10 units, a circle with the radius equal to the stress, a point on the tau axis at a distance 10 units, a point on the sigma axis. Actually, tau axis is the y axis, sigma axis is the x axis. So this is our answer. We'll be plotting in the sigma axis, a point on the tau axis, point D is the answer. So these are the questions that is from the GATE 2020 for the first session. I will be discussing the more questions from the session 2 in the next class. Thank you.